For a while, eh? Ganda ba tayo? 1, 2, 3, 4, 5, 6, 12. 12 pa lang. Ngayon lang. Nga ba tayo? 14, 12. Ah, pwede na, no? Okay, so next, we're going to solve multi-stage leaching problem. Ano? So sa multi-stage leaching problem, we're going to use this equation. Ano? This is known as the absorption factor equation or the absorption factor method. Ano? So meron pang ibang pangalan to. So check nyo na lang sa handbook. Pero this is the most commonly used name for this equation, absorption factor equation. Ano? So you can find this on page 18-66 of the 8th edition handbook. No? So N corresponds to the number of theoretical stages. Can you hear me? Okay. So eto na, let's locate this concentration, yung mga YB, XB. So halimbawa, this is your multi-stage leaching diagram. Ano? We have nth stage leaching process. Dito pumapasok yung solid, no? Ito yung underflow. So this is L sub O. Ito yung feed. Tapos ito yung final underflow. Tapos ito yung solvent, Bn+1. Okay. So nth stages, ano? Ito yung final extract B1. Okay? Yung YB, this YB refers to the concentration of your solvent. Usually zero lang yan, ano? Yung YB. Tapos yung XB naman refers to the concentration of your final underflow. This one. No? Tapos yung YA refers to the concentration of the solution coming out of stage number 2 or yung pumapasok sa first stage. So this is nandito yung YA. Yung XA naman, yun yung lumalabas sa first stage, ano? So, if you will notice, hindi natin sinasama yung stage number 1 sa calculation, no? Ng number ng stages. So pag binasa nyo itong page na to kay Perry, itong 18-66, so nakasulat doon, kailangan bawasan nyo ito ng isa. So actually this is n-1, no? Natandaan nyo na merong n-1 dito when you're finding n. So pag pipindutin nyo sa calculator, lagay nyo n-1. Okay, so how do we justify the absorption factor equation? So basically, ang absorption factor equation, ano lamang yan? Yung n-1 stages, equal lamang yan sa average range divided by average approach. You're still familiar with range and approach from your CHE 133. So, ito, yung halimbawa YB minus XB, ang tawag dito ay approach or range. Of course, approach. Magkatapat kasi sila, di ba? So, yung YB minus XB, this is approach, no? Approach yan. Yun ding ano, YAXA, YA minus XA, approach din yan. Ano? Yun namang ano, halimbawa YB, kasi mas mataas yung concentration ng YB, YB minus YA, yun naman yung range. Okay? So, imagine niyo ano, pag yung total length, dinivide nyo ng unit length, you're going to get the number of stages. Ganun lang yun. Ano? Parang ano lang yan, parang tiles lang sa bahay. Halimbawa, yung sala nyo, 20 feet. Tapos yung bawat tiles, 1 foot. So ilang tiles yung gagamitin nyo across para mapunan yung isang ano ng sala. Isang hilera ng tiles ng sala. Diba? 20 divided by 1, you will need 20 tiles. Ganun lang yun. Ha? Okay? Does it make sense? Is this equation make sense to you? Average range divided by average approach is equals to the total number of stages. So tandaan nyo, may minus 1 kasi dito tayo nagsimula. Ini-chopera natin yung number 1. Okay, so the next question is, bakit nga ba ini-chopera yung number 1? Bakit hindi natin dito ilagay yung x sub a natin? No, ba't hindi dito? Bakit hindi dyan natin nilalagay yung x sub a? So ang answer kasi dyan, yung L sub o solid. No? So pag solid yan, generally mixture yan. Pag mixture, walang limit yung concentration. No? So pwede siyang mataas na mataas, no? Remember, we are speaking of average. Yung ating formula involves average. Pag yung may extreme value ka, yung average mo will be very much affected. Okay? So dito sa yung lumalabas sa first stage, ito, ano na yan? Concentration na yan sa liquid. Concentration na siya. Solution na yan. So yung solution may limit siya. So maliit yung probability na magkakaroon kayo ng extreme value pag ito yung ginamit natin. Ano? Okay, so that's why hindi exclude yung first stage kasi solid yung pumapasok. Pag solid, may possibility na extreme yung value ng x sub a pag doon natin nilagay. No? So that's why ang formula natin merong n-1. Okay, so let's take a look at the formula for average range. Ano ba yung average range equation? So, masikip ano? Average range. So alin ba yung mga range? Ito ano, yung YB minus YA, no? So ang average range natin parang ano, parang logarithmic average. So ang average range natin is YB minus Y sub A. Okay? Sa taas ano? Sa baba naman minus XB minus X sub A. Parang ano to, parang delta T ln TD kung tandaan niyo pa. So sa ilalim we have ln YB minus Y sub A divided by XB minus X sub A. Tama? Parang logarithmic average siya. Di ba ganito rin yung sa delta T ln TD? Ano? So ganyan yung average range. What about average approach? So yung average approach naman, I'm trying to justify the absorption factor equation. Yung average approach naman is yung magkatapat ano, halimbawa YB minus XB minus YA minus XA. Tapos divided by L, ano ba to? Log pala to, no? Log yung gamitin natin. Rest lang naman yun. YB minus XB divided by YA minus XA. So if you divide the two, halimbawa yung average range divided by average approach, ano ba dinivide natin yung dalawa? Notice that this YB minus YA minus quantity XB minus XA is the same as YB minus XB. Negative din yung XB, di ba? Parehas ng YB. Parehas ng negative XB. Tapos negative YA din, ano? Positive XA. Positive XA. So you can cancel this out, these two. So yung matitira yung dalawang log. So yung nasa taas is log of YB minus XB divided by YA minus XA. Tapos sa ilalim is log of YB minus YA divided by XB minus XA. No? So ito yan. Ito. Question. Do you have any question regarding the justification of the absorption factor equation? Wala? Malinaw? Okay. So, in solving problem, multi-stage leaching, usually meron dalawang cases. Ano? Yung case number 1, yung unit ng retention, this N is retention, tawag dyan. This is the amount of liquid that is being retained by the inert solid. Ano? So, if yung unit ng retention natin is kilogram solid per kilogram solution for case 1, yung concentration should be in terms of kilogram solid per kilogram solution. No? Sa case 2 naman, pag naman yung N is in terms of kilogram solid per kilogram solvent, ganun din yung unit ng ng solution, ng concentration. Ano? Kilogram solute per kilogram solvent. Question. Okay? Nakita niyo yung pattern? Pag ang retention per kilogram solution, ang concentration nyo per kilogram solution din. Case 1 yon. Pag naman ang retention is per kilogram solvent, yung unit ng concentration per kilogram solvent din. Okay. So mamaya makikita nyo, pag nagsosolve tayo ng problem, tapos case 1, mag-overall mass balance tayo. Pag naman case 2, magso-solvent balance tayo. Hindi tayo mag-overall mass balance. Ano? Mamaya makikita nyo. Okay, so let's try a problem. So let's try a case 1 problem. This is from the MRI reviewer. No? So coconut oil is to be produced from dry copra in 2 stages. First, through expellers to squeeze out part of the coconut oil. So pinipiga muna para makuha yung oil. And then through a counter-current multi-stage solvent extraction process. Tapos yung pangalawang stage, leaching. So after expelling, pagkatapos mapiga, the dry copra cake still contains 20% residual oil. May oil pa, madami pa. In the solvent extraction operation, 90% of the residual oil in the expeller cake is extracted as a solution containing 50% by weight of oil. If pressed solvent is used and 1 kilogram of solution, if pressed solvent is used and 1 kilogram of solution with every 2 kilogram of insoluble cake is removed with underflow, the number of ideal stages required is blank. So, anong case tayo? Siyempre, nasabi ko na sa inyo, case 1. Kasi tingnan niyo yung retention. Every 2 kilogram of inert will retain 1 kilogram of solution. So, case 1. Case 1 tayo. So, expect na mag-overall mass balance tayo. Okay, so I think mas magiging orderly yung solution natin pag nag-whiteboard tayo. Maging magulo dito. So, mag-whiteboard tayo. Okay. So we have a multi-stage leaching problem. 1, 2, and okay. So kung tandaan nyo pa, i-assume natin, basis natin is meron tayong 100 kg ng copra. You're familiar with copra, yung tawag sa dried coconut meat. Tapos it contains 20% oil. Okay. So, yan yung feed natin. Then, I think wala namang given na value ng solvent. So, let's just call this Bn plus 1. Hindi rin natin alam yung kung gaano kadami yung underflow. What we have, I think, is yung concentration ng extract is 50%. Let me check it. Yep. Yung concentration dito is 50%. This is 0.5. Tapos ang retention natin, 1 kilogram of solution is retained for every 2 kilogram of inert. So basically, ang tinatanong number of stages. So in order to solve for the number of stages, dapat alam niyo yung mga values ng apat na concentration. Yung X sub A, yung X sub B, yung YB, no? At saka yung Y sub A. Basically, ito yung hahanapin nyo. Kasi ito yung mga variables dun sa absorption factor equation, yung apat na yan. Ano? So for example, di ba, wala namang sinabi regarding dissolvent. So pag walang sinabi na ganun, i-assume nyo na pure solvent siya. So yung YB nyo, 0 lang yan. No? Tapos another thing, ito di ba? What's the relationship between Y1 and XA? Anong value ng XA? Halimbawa,
Equal to Y1 po.
Very good. Ano, always remember that, no? Always remember that yung value ng XA equal sa Y1. So ito 0.5 din. Okay, so as you can see, dalawa na agad yung alam natin, ano? So in order to solve X sub B naman, this is always kilogram oil divided by ln. Ganun lang yan. So hanapin muna natin yung ln, ano? So that's the first step usually. Naghahanap tayo ng ln. Ganyan naman palagi sa leaching. Kahit multi-stage, ln yung una nating hinahanap. Ano? So, ang ln depende dyan sa amount ng inert. So, 20% oil. So, 80 kg yung inert, di ba? Tama? So, 100 kg ng copra. Tapos, 80% non-inert. So, times 0.8. Tapos, ito ay multiply nyo itong 1 kg solution per kilogram of inert. Per 2 kg. So, magka-cancel to. So, ang L sub N ay 80 divided by 2, 40. Ano? 40 kilogram solution. Question? Yun. So, alam niyo na yung L sub N. You can now calculate X sub B. Kasi sabi sa problem, ang rate ng extraction ay ganyan ba yan? Merong given na rate ng extraction. Ano? Wala pala. Okay, mamaya na. So ito muna. Let's try. Actually, what we can do is we can solve B1. Sabi parang may rate. Hindi lang Ang rate of extraction is 90%. Ano? 90% ang rate ng extraction. We have a 90% extraction rate. Ibig sabihin, 90% ng oil may extract, no? So, yun, after calculating 40 kg, we can now solve XB. Kasi yung kilogram oil na matitira dito, 10% na lang. So, 100 times 0.2, this is the total amount of oil, tapos times 10%. Question? Tapos divided by L sub N na 40. So, XB, use your calculator. So actually, as you can see, this is the third, ano? This is the third value of concentration. One over 20, so 0.05, ano? 0.05 yung X sub B. Do you have any question at this point? Okay, so pag meron ng X sub B, next is we need to solve Y sub A, ano? Yun na lang yung wala kasi meron na tayong X sub A, X sub B, Y sub B. So Y sub A na lang. So generally, in order to solve Y sub A, mag-ano tayo, mag-oil balance tayo dito sa 1. Pero before you can solve that, dapat alam mo yung value ng lahat ng variables. Except for Y sub A, you know? Halimbawa, ano yung flow rate ng dito? No, yung L1. L1 yan eh. Yung flow rate ng L1, equal lang yun sa Ln. Ganun na, no? Kung ano yung flow rate ng Ln, yun din yung flow rate ng L1. Kasi constant yung ating retention eh. So, ito constant yung N. Ano? So this one is also 40 kg. Okay? Tapos ito, you have 100 times 20%. This is, you also need to solve for B1. Ano? So B1, before you can perform oil balance at 1. Ano? So let's try to solve B1. It's the second step. So basically, gagamitin natin yung value ng Y1. Ang definition ng Y1, kilogram oil divided by V1. Do you agree with this equation? Kasi di ba ang unit, pagkatulad nito, case number 1, kilogram oil divided by kilogram solution. Yung solution natin is B1. Okay lang? Regarding formula for Y1. Okay, so let's proceed. So ang Y1 natin is given as 0.5. So ang kilogram oil nito is 90% ano, ng 20 kilogram. 90%. Tapos yun, you can calculate B1. So B1, what will be the value of B1? So 20 times 0.9 divided by 0.5. You're supposed to get 36 kilogram. Ano? 36 kilogram solution. Question. Do you have any question? Yun. So this is 36. Yun. Meron na yung lumalabas, yung pumapasok, yung lumalabas ng isa. Dito, ang kailangan na lang natin dito yung kung ano yung, kung ang B2 naman, this is B2, ano? That's B1, this is B2. Yung B2 naman, equal yan sa Bn plus 1. Ito, equal yan dito. So, kailangan natin hanapin to. So, ang gagawin natin, mag-overall mass balance tayo. Number 3. This is step number 3. Ano? Overall mass balance tayo. Kasi case 1 to, kaya nag-overall mass balance. Okay, ganun pa rin. Kamukha ng leaching kanina. Sa overall mass balance, yung oil lang yung i-consider natin diyan sa sum inert. Ano? So, 100 times 0.2. Okay? Tapos dito, yung Bn plus 1. Pumapasok kasi, di ba? Parang sila pumapasok. Tapos yung lumalabas, yung Ln natin ay 40. Ito, 40 to. Ano? It's 40 kilogram. Do you have any question at this point? Tapos yung lumalabas doon sa B1 is 36. So you can solve Bn plus 1. 76 minus 20, 56. Ano? 56 kilogram. Yun. So 56 ito. Yung B2. This is 56. Tapos this is 56. Can you follow? Do you have any question? Okay. So at this point, kung kita nyo, kompleto na yung data natin except for Y sub A. So we can perform a oil balance at stage number 1. That's the 4th step. No? Oil balance at step 1. At stage 1. Okay? So let's start with this. So start tayo dito. So 100 times 20%, that's 20 kilogram of oil, di ba? Tapos, yung pumapasok sa taas, that would be 56 times Y sub A. Y sub A kasi hinahanap natin, di ba? Tapos, parehas yung concentration ng taas at saka baba. So both of them are 0.5. So 0.5 times, sa baba, we have 40 ang flow rate. Sa taas, ilan? 36. No? Can you follow? So calculate nyo na lang ang Y sub A. After calculation of Y sub A, kompleto na yung data natin. Ano? Papasok na lang natin sa absorption factor equation. So you're supposed to get something like 76 times 0.5 minus 20 divided by 56. 0.32. Ano? Y sub A is 0.32. Are you getting the same value? Do you have a question? Equal. Yes, very good, sir. 0.32. Nasundan? Nakasunod? This is the classic coconut oil problem. Ano? Yan, Sam. Yung ginagawa sa Franklin Baker. Pupunta ka na ng Franklin? Yan, meron sila ng leaching. Okay, do you have any question at this point? Do you have any question at this point? So basically, papasok na lang natin doon sa sa absorption factor equation. Kasi meron na tayo ng 4 na concentration. So let me, wala ba itong next page? Parang meron tayong next page. Okay, parang hindi ko makita. So I'm going to clear this and then i-recall ko na lang yung absorption factor equation. Ano? Okay. So pasok natin yung lahat ng concentration sa absorption factor equation. Probably it will help if we're going to rewrite all the concentrations. Ano? So dito, 0.5. Tandaan niyo pa ba? Dito, XB, 0.05. Dito, YB, 0 lang. Okay? Dito, XB, ano nga ba XB? Yung huli natin kinakita ng 0.32. Ayan. So yung 4 na yan, papasok ni lamang dun sa N-1. This is the absorption factor equation. Log. Memorize nyo YB minus XB. Ang hint lang dito yung nasa taas ay approach. YA minus XA. So denominator naman, ang hint, range, YB minus YA. Okay? XB. Okay? Ako, hindi ako nagdumidiretso sa calculator. Kaya kung gusto nyo magdumiretso sa calculator, kaya nyo, okay lang. Ako sinusulat ko sa papel muna. Tapos saka ako kina-calculator. Tapos pag sulat ko, sinasabay ko yung taas at baba. Anyway, this is my technique. It's up to you kung gusto nyo i-add the point. So, halimbawa, YB, So, 0, 0, 0 muna, tapos minus, minus, tapos XB naman. XB natin ay, sorry, this is supposed to be YA. So, ang XB natin ito, 0.05. Sa baba, Kasunod pa? Kung gusto nyo dumiretso kayo sa calculator, walang problema. Y sub A is 0.5. No? This is Y sub A. So this is 0.5. And then finally, we have X sub A. X sub A yung dalawa sa baba. So this is X sub A, 0. This is Y sub A, 0.32. Pakipalitan. Itong sa baba is 0.32. Dito ako. YB minus XB sa ilalim, YA. This is 0.32. Okay, and then finally this one is XA. This is XA. So XA is 0.5. So do you have any question? Pasok niyo na sa calculator tapos shift solve. So alpha x minus 1, alpha equal, tapos log. Okay, so we have 0 minus 0.05, 0.32. Minus 0.5. Sa ilalim is 0 minus 0.32. Tapos 0.05 minus 0.5. Okay, tapos shift solve. What do you got? Yep, very good. 4.76. Very good sum. Carla, 4.757. Very good, Carla. No? So you're supposed to get 4.76. So that's the classic. So this is approximately equal to 5. Then yung answer sa problem is 5. Even if do you have MRI? May MRI book na kayo? Do you have any question regarding these problems? Okay, so kung wala kayong question, I will let you solve, no? I will let you solve the single stage, the case 1, no? The first multi-stage problem. I'm going to give you 15 minutes, no, to solve that. Try to solve the first problem. It's in Blackboard, ano? So ito yung sunod natin. So letter D yung answer. Tapos, ito yung nasa exercise. Ano ito? Hindi. Ito ata yung nasa exercise. Ha? So, let me check it. Copper sulfate. Oo, ito nga yan. Ito nga ang copper sulfate yung nasa exercise. Oh, what did I do? Mali yung pindot ko. Leaching. Yan. Ito yung next exercise. So, kung hindi nyo pa nagagawa, please try to solve this problem. Ano? This is also case 1. Solve nyo muna to. Oras na ba? I think it's 3 o'clock, ano? So, mga 3:30. Yun. So, 1 to 4 tayo. Ano? Probably pag hindi natin natapos, kasi 3 o'clock na rin naman. Tama ba? 3 o'clock na. We will continue this on Tuesday, ha? Tapusin natin yung leaching by Tuesday. So para by Saturday, we'll finish liquid extraction. Para makapag-prelims tayo on the 4th week. We're on the 2nd week, no? So try to solve this one kung hindi nyo pa nasa-solve. Okay, so I'm going to give you mga 15 minutes, ha?